All right, good evening, everyone. I just now realized that I picked a sweatshirt that matches the background that I chose in Thunkable here. So on the stream tonight, this is a shout out to Rudd Dog, a follower from the beginning. Anyway, he's been trying to create an Android app that can talk to an ESP8266 and doesn't have a lot of experience coding. And so he was looking at some low code slash no code options, things like Blockly and other options. MIT App Inventor was one that he messed with, and I looked at a little bit. And so I told him I'd shoot a video of me trying to get something like that, an Android app talking to an ESP8266 via I'm going to do Thunkable. I found a couple of options, and I've never personally tried low code or no code. And so this is a first for me. All I've done is I created an account. Um, I went through the getting started tutorial. It's about 9 minutes long, and it results in what you see here. And I'll show this to you in a second. And then I have a Galaxy S8 right here. It's kind of my dev phone that I installed the Thunkable Live app on. And I got to tell you, I'm pretty impressed right out of the gate. And so all I've done here is dragged on a text to speech item, which you can see over here in the tree view. You can add components from here, and then a button. And then I've also got a web API there that I'll actually delete because we'll play with that in a minute. That was me trying to get a head start. So right now, this is just the Thunkable introduction tutorial. And let me show you how it works. Oh, yeah. Let's see. Okay, so you dev this in the IDE, what you see right here on the screen. And then when you open the Thunkable Live app, so the light's not going to work. You can see that. Okay, it's the same thing, like exactly the same. It literally just, I don't know how it works, but it connects, the app connects to your dev spot here. And in the button here, I'll come over. So this is the design where you drag stuff onto the screen and lay it out however you want. And then if you come to blocks, this is just like a Blockly-like programming language. I don't know if there's a way to, like, if you know how to code to do it. I think you have to do it through like the block design like this. And you can just see button one, when button one click, do text to speech, speak. This is freaking awesome because it is pretty awesome. So let me turn up my volume here. That's ringtone. Media system. I don't know. Let's just crank it. All right. And so I'm going to push the button. Check this out.
This is freaking awesome.
Like, that's it. And then just show you this isn't smoke and mirrors. Let's change it up here. I don't know if I can. Oh, let's zoom so you can see this a little better. Hello, Twitch. Whoa, Twitch. Yep. So I just changed it there in the web IDE, and check this out. Like,
hello, Twitch.
Like it's instantaneous. Like it syncs instantaneously with the phone. And so this is how you would dev. There's options, I believe, right here. Publish. You can publish to the App Store, iOS, publish to Google Play, or publish as a web app. I'm not super concerned with doing that right now. I just want to show that you can actually get the app working, and then I'll leave it maybe as a future video to figure out how to actually get it into a store, because I'm not trying to make it that far. But so what I want to do,
hello, Twitch.
it's so cool, is see if I can get the app talking to, where is it? One of these is an ESP8266, the Feather Huzzah 8266. And so let's see if we can get this to work. That's what we're going to work on. And to get started, I think we'll start. The Arduino IDE is not letting me like break it out here. What's happening here? Why are you being difficult? It's not letting me like resize it. It's just letting me slide it. All right, let me close it and try it again. Arduino. All right. See if, no, it's not letting me. I guess because I have it like, there we go. Man, I think that was a Pop OS thing. Okay. So this is not the sketch I want. So let's just copy all this. Control C. We're going to take a starting point that we have. We'll say new. Drag this over here. Get rid of this guy. So I think the way we're going to approach this is I've actually never run the server on any IoT device for that matter. It always acts as a client in the applications that I've done over the years, talking to cloud services or a local network server. But what we're going to do is we're going to turn this into a little mini server, like another computer running on the network. It'll listen for commands from the app. So we're going to try and just hit it. It's going to be a little hard coded to start, but I'm hoping we can get far enough to illustrate what we're trying to do here. So let's do that. Make this a little bigger. And we're going to gut a lot of this out. This was from my deploy the fleet stuff, so we can get rid of that for now. ESP Wi-Fi credentials. Yep. We don't need any of this. This is just helper code. Set up serial begin. We do want to begin, and we'll say Thunkable example. And we don't really need this setup wait, but we'll leave it in there because it's kind of nice to be able to give you a second to attach to the debugger. So let's save this. We'll save it as Thunkable. Okay, and then we start Wi-Fi mode. Now, I don't know that this is how we need to do this. Well, I mean, it's got to connect to the network before it can be a server. So I'll just look up an example. Like I said, I've never done an Arduino as a server. And then let's just get rid of the entire loop. We don't need any of this for now. Okay. Great. And then I need to add credentials. I'll come off the screen here for a second and do that. Sketch. I need to just new tab. There we go. Credentials.h. And then it's Wi-Fi SSID and password. And Wi-Fi SSID. And pound define Wi-Fi password. Okay. So we should be all set there. And then actually, let's open recent. Let's actually just test. You should always build and run as often as you can. We'll do if Wi-Fi. I do want to keep some of that code that we had in the loop here. So we'll wait for the Wi. We'll just make sure it connects. If Wi-Fi connects, baseline is working. Okay, we'll just print that out every 5 seconds. So let's just make sure we've got something that's working to start. Hope everybody's doing well Saturday night. Okay, let's do upload. Oh, it's probably on the wrong. Oh no, it looks like it's in the right board. Forgot to set the board. Tools, board is the Feather Huzzah, and then the port is not going to be TTY. Yeah, that's going to be wrong. Let's let this out of Reese. Tools, port. I don't think it's going to be that, but let's try again. Essentially, we need to get a, there we go. It is TTY USB 0. All right, and it is writing the firmware. I've learned many times, don't try to open the serial monitor while it is flashing because it will bork the flash. It doesn't like brick the device or anything, but it'll mess up the flash. I have to do it again. So we'll let that finish all the way and then boot up. And now we'll open. Sweet. Check that out. Baseline is working every 5 seconds. Great. Okay. So our device is programming and working and all that. So next up is, let's get just a Arduino core. I want like Arduino core ESP server. Okay. Setting up a web server on the ESP8266 requires very little code and is surprisingly straightforward. This is thanks to functionality provided by the library. All right, so we'll just copy the code here. This is where we do code copy. Let me look at this a little bit. Okay. Once a new client is connected, we'll come back to that. Let's just start with baby steps. So right here, we'll say Wi-Fi server, server 80. I don't know if we have to, it didn't say we have to have a header. So let's just start grabbing some of this code here. And we'll look through it here in a second. The header is to inform the client. Yep, we know that. The connection will be closed after serving and the content should be requested by the client again every 5 seconds. We don't need to do that. Okay, yes, we do not after completion of the response. Yeah, we're not going to send the refresh. So this is what we need to do. Once a new client is connected, server will read the client's request and print it out on a serial monitor. Okay, cool. Is there just like the entire, here we go. There's got to be a, have we just done the whole thing here? All right, well, let's actually just take the whole thing. We do need that header. There we go. I think I already have that. ESP8266 Wi-Fi? Yeah, okay, cool. Let's just grab the whole example and then we'll look through it and, whoa, change it to our liking. Okay, cool. So we do need to include credentials. Let's just do this. All right. Now we are running the sample code from the documentation. So setup, we're going to begin connecting to, I do not want to print out my SSID. So we'll just say connecting to Wi-Fi. Wi-Fi.begin. This is Wi-Fi SSID. And these I'm just getting from like off screen in this credentials.h file, which I'm not going to show you because it's my Wi-Fi password. I just defined Wi-Fi SSID, but you can do it just like it shows in the example here. You can just define those right here at the top of the file. I chose not to because I'm being difficult. I don't know. Wi-Fi password. I mean, it's really so I don't show you my Wi-Fi password. Not that it's the end of the world, but okay. While Wi-Fi status is not connected. So in the setup, we're going to wait until it connects to the Wi-Fi. Oh, and it's going to print a dot every 500 milliseconds. That's fine. And then it will print line connected. And then it's going to say server.begin. So this is what's going to start the server on our 8266. Web server started. Open this in a web browser. Okay, cool. So it's going to give us the local IP. That's awesome. Prepare HTML page. Let's see what this does. HTML page.reserve. Great. I don't want this refresh. So I'm just going to take that whole line out. I don't want the page to automatically refresh. Interesting to integrate this in with something like a Wi-Fi manager. Okay. Analog input. Okay, we're just going to actually say hello from the ESP8266. And then we're not going to append an analog read. And, oh, then we're adding the closing. Yeah, okay. So for those that aren't familiar with HTTP, like it's really just text that's going over TCP protocol, but you have to pass like, this HTTP version, the response code, okay. The content type is text HTML is what we're returning. This could be changed to something like text /JSON or, something like that. Connection closed. These are the headers up here. And then this new line /r/n takes us down into the body. So everything above this is, well, these are the headers. And then this is the, I can't remember what they call the very top part of the HTTP response. And then this is the body of the response, everything down below. And then we finish it off with another new line at the end to let it know we're finished. And then we return the HTML page. I'm assuming we're going to call that down here somewhere. So client equals server.available. So this is just going to run in the loop. If a client connects to our device, oh, there we go. We'll jump into this if statement. We'll say client connected, and while the client is connected, read line by line what the client is requesting. Cool. And then we'll print that out. It's marked with an empty line. We're going to have to do some manual stuff here. I can feel this already. I'm sure there's libraries that can get things like query params, but we'll cross that bridge when we get there. If line.length equals 1, and it's a new line. Okay. Cool. And then we just do client.println. And remember, prepare HTML page returns the response. And so we're basically going to client.println is write out the response. And then that's weird. Oh, while client.connected. Okay. While client, but first let client finish its request. That's diplomatic compliance to protocols, and otherwise some clients may complain, like curl. That is an example. Prefer using a proper web server library. Okay. So this is apparently just to make things work. And then we're going to do client.stop and then disconnected. I don't know. Let's try this thing. Let's run it. Let's upload it. See if it builds first of all. Cool. I wonder how much space it needs. 26 and 33. Oh man, it's like using no space. Wow. Cool. Oh, we need to get this back. Web server started. Open 192.168.1.17 in a web browser. Oh, watch this. I'm going to copy that. And then let's open it. Hello from the 82. That's really small on the screen here. Hello from the ESP8266. That worked marvelously. And let's take a look at our output. Very cool. So we got client connected, and then here's the request, get HTTP 1.1. And this is where we're going to have to do some things later. I can't remember what it's called, the very first line of the request, because it's got the method, it's got the path, it's got the HTTP version. And then here are the headers: host, connection, do not track, because I'm using Brave, upgrade insecure request 1, which we were unable to do. Cool. So it sends all of that stuff. That's great. Oh, and client, Brave also tries to get the fave icon, which doesn't exist at this path, although I don't think we'd probably return the same thing. We probably just, no matter what the request is, like, let's just test that really quick. This is nonsense.html. I feel like it's going to give me the same response. And it does. Okay. And the reason for that, again, if you're not familiar with HTTP, is because all we're doing in our loop is saying, if somebody connects, I don't care what path they're asking for. So what this is nonsense.html. I don't even care what that is. Just return prepare HTML page. And so, cool. All right. Well, that's working. Now, let's see if we can get the app to speak this. Hello from the ESP. Let's change that so that the text to speech can like have a chance. It's going to say ESP8266. Yeah, we're going to make it say that. So, I don't want to return it as HTML though. I want to return it as text dot. I don't really want to do JSON. Turn types. No, this is not. GP content type. It's a meme. I don't know how you say it. And I just want it to be like text slash, is it txt? Like, can I just do text? Text HTML, text JPEG. Let's just see what all the text slashes are. Oh, text plain. There we go. Okay. So I'm going to just set this to text plain. And that means, hey, whoever's requesting this, in this case, the browser, we could do it through curl or other things. Don't worry about, you don't have to format, or it helps it know how to format it if it can handle it. So Brave will just splat it on the page. And so we can get rid of this. We can get rid of HTML. And we can get rid of this HTML as well. We can just finish it off with a new line. I think that'll work. So I'm just going to return text plain, connection close, hello from the ESP, and that should just return it as raw text. Save it. Let's upload it. And see what we get. We're not doing too bad. 20 minutes in. Like, I'm feeling pretty good about this. Clear output. Did it start up? What happened? Oh, it's still programming down here. Okay. Web server started. It's still 1.17. Normally when it connects to your router, it'll keep the same address for a while. So now let's look at, you might see that the format changes a little bit. So let's take a look. Yeah, okay. See how it's a slightly different font because Brave's like, it's not HTML, so it's just raw text. I'm going to display it. Now what we can also do, let's just grab the IP address. And then I'm going to launch a program called Postman. If you've never used it, it's just a handy, like if you don't want to use the browser and you're not feeling like you want to get down into like curl or wget, Postman's like a really cool way to just say like, hey, request get 192.168.1.17, and then I'm going to just hit send, and then you'll see I get the response here. I've got extra new lines. That's weird. But anyway, it'll show you the response. It'll show you the status and how long it took and all that other stuff. And this will come in handy maybe in a minute when we want to play around with it some more. Why are we getting an extra? This is probably unnecessary. Well, the line for sure is unnecessary. Let's just do that. And then get rid of this altogether. Like that. That should output the same thing. And we're not going to build and run that right now. So, cool. Let's go back to the docs for a second. Oh, check out other classes like ESP8266 web server that let you program more advanced applications. Oh, geez, you should have led with that. Does this have a full example? Yeah, this is what we're gonna want. Let's okay. Advanced web server. Hello server. Let's see how crazy it is. Yeah, okay, here. So this is what this is. Server.on/gif, and then we can return, or GIF, however you say it. Server.add hook. Oh, that is a little, for sure, a little bit more involved. Before I go into that, I just want to show you, if you're interested, if you wanted to do, well, I wouldn't recommend it for if you're just getting started. What you would have to do is, let's come back. You see how it's saying get, this is nonsense.html. What you would have to do is you'd have to do some parsing to say, does the line start with get space, get space slash maybe? And then you'd have to parse out this part right here to say, if it's this is nonsense.html, do one thing. If it's this is not nonsense.html, do another thing. And so you're gonna have to do a lot of string parsing. What I'm thinking that the web server will get us here is that we won't have to worry about that. Like it has, advanced web server might be a little bit too advanced. Oh, it doesn't look too bad. Yeah, so like this. Instead, you can do server.on, like handle root, server.on, draw graph. I think this is perfect. Let's take this. Yeah, let's take this code. We're going to switch off of the simple one and we're going to go to advanced. Let's go advanced example. All right. Okay. And we're going to have to pound include credentials.h. And we're going to say Wi-Fi SSID and Wi-Fi password. Okay. Great. And then now we're, instead of doing a server, we're doing an ESP8266 web server. Constant LED. I don't know if the Huzzah has a. It does not. Oh no, it does. Digital. We're gonna call it LED built-in. Handle root. Digital write LED 1. What is all this? Uptime. Oh, it's going to tell us the uptime. Hello from ESP8266. It's going to tell us the uptime. And it's going to give us a test.svg. Where are we getting that from? Oh, because down here, interesting. Okay, well, let's just see what this thing looks like. Okay, cool. Hour, minutes, server send, handle not found, draw graph. So this is going to draw the SVG. That's fancy. Pin mode, LED output, digital write, LED 0. Wi-Fi mode, begin, serial print. We're going to just, again, not print out our SSID. For me, there's nothing wrong with that. I just don't want to expose it. Connected to Wi-Fi. IP address we're going to need. Responder started, and then it's going to set up all these routes. We're still in the setup loop here. So when you request the route, you're going to do handle route. When you request this test SVG, which route does, it's going to do draw graph, and then on inline, it's just going to do, oh, see, this is really great. Server.send 200 text plane. This works as well. This is really helpful. Okay, cool. And then if not found, which will be, again, if you just type in something nonsensical, that's what's going to run. Server.begin. All right, this is going to be awesome. Let's program it. This is going to be really cool. And we'll simplify quite a bit what we're trying to do with connecting to our phone here. Just wait for it to program. Can we get this done in under an hour? It's going to be tight. I think it's going to be tight, but we're going to try. Okay, server started. Down here, it's still 1.17. MDNS responder started. HTTP server started. So now we're going to forget Postman for now. We're going to come back up here. Oh, I closed it. 192.168.1.17. Cool. Oh, yeah. Check that out. Oh, and does it? It's refreshing. So check out the uptime, 42 seconds, 47. So it's doing that refresh every 5 seconds. I hate that. I mean, it's cool that it does that. And if you want it to do that, that's fine. But I'm going to need to fix the headers for that. How do I do that, though? So handle root. There's nothing that says it should keep doing that. So let's come up to handle, not found, handle root, printf, HTTP, head, I print all of that, server.send. There's nothing about it that says it should keep requesting. Maybe when we do SVG, draw graph. How are we sending refresh? Where am I missing that? Oh, there you go. It's embedded in the HTML as a meta tag. Okay, so let's get rid of that. Oh, we can get rid of the whole line. Okay, save, and that'll keep it from updating. But it's really cool because it shows like the uptime. It's been up for 2 minutes and 9 seconds now. And hello, and it's got some formatting. Really cool. And now if we do something like we did before, this is nonsense, we should get a not found. Method get, this is coming from the ESP8266. Like it's returning this. Cool. All right. Oh, and then what was the plain text example? Inline. So if we just go /inline, beautiful. And then we can do that. Bring over Postman and say inline, send. This works as well. Great. Okay. So now I'm not going to worry about cleaning up the code that I don't care about right now. We'll leave everything there. We don't need we don't need to serve up a web page is what I'm, I guess, getting at. But let's just say voice. We'll say hello from the ESP8266. Okay. And then let's upload that. The 8266s are amazing. They're really slow to flash. I've said this every time I'm programming one, but they are. They're a little slow. The ESP32s program way faster. But such capable little devices and really crazy, these little things. Really cool. Okay, HTTP server started. And let's just test it real quick. Inline. Uh-oh. Oh, because it's not inline anymore. I changed it to voice. Voice. Hello from the ESP8266. And I'm going to do it one more time to see what the LED does. Nothing. Okay, that's useless. All right. Now that we have that working, let's come back over to Thunkable. And let's say is this still working? Okay. And I got to log into my phone here.
Hello, Twitch.
It's not still working then?
Hello, Twitch.
Still saying hello. How do I save? Or did it like... Is this still working? Should be.
Hello, Twitch.
Uh-oh. So it's not still working. Let's come back to design. Maybe it like logged me out. Preview, great. Okay, now it's... did it log me out? All right, I'm just going to refresh the page. Okay, let's go back to blocks. Is this still working? Just turned off on me.
Is this still working?
Ah, there we go. Hear it.
Is this still working?
Okay, it is still working. Okay, now let's do some no-code stuff. So we've got our design here, and let's change a few things. The button, for example, let's change the text to, I don't know. Let's just say ESP8266. I'm not being very... What's crazy, and you can't see this, and the camera's not gonna work on it. Like, it updates in real time. Like, as I'm typing it in the editor here, it's updating right here on my phone. Like, the integration is pretty slick. Like, I've got to give them serious credit for that. Thunkable, great job. So we can change things like that. We can move it around. Let's, like move it up here. Maybe. Can we not move it around? You're not gonna let me move it? But like really I want to move it. How do I move it? Visible true. Font bold, like, do I have to? But I want to move it. Okay. Font size 18, text and background color. Now I'm on the screen. Now I'm on the button. Rename, duplicate. Why wouldn't it let me just drag it? That's weird. Like, I want to put it right there. Huh. Pick one. Fit contents, fill container, fit pick, okay. Relative size? What's that do? Fill container. Whoa. Okay. That's weird. Fit contents. Yeah, okay, great. And that's all cool. Like, but how do I move it? Raised. Okay. All right. Well, I guess for now, what happens if I drag another button on here? Just stacks it on top. I wonder if this is part of the screen. Screen oriented status bar. That's really weird. All right. Well, I'm not sure how to move. I'm going to get rid of button 2 for now. Yes. Maybe an advanced positioning. Flexbox layout. Okay. Gotcha. Maybe we see relative. Now we can drag it around. No. This Flexbox stuff. Like, I remember doing this with WPF when I was at Microsoft. Like, the positioning sometimes is crazy. So, absolute. There we go. Now can I drag it around? No. No. Okay, relative. All right. Well, flex. So if I change this to 0. I'm sure there's documentation on how this stuff works, and I just don't know it. Flex direction. Column. Flex direction row. Oh, here we go. Justify content. Flex start. Okay, there we go. Align items. Center. Flex start. That's going to be put up in the... Okay. All right. So that's great. I'm not going to mess with that right now. Okay. You have to mess around with moving things.
Is this still working?
It's still working. Okay. But the important part is let's make the button do something, like send a message to our ESP8266. And then the idea on this is once we can send a message, we can do anything. Like we can run any kind of code on our ESP8266. And then the how to design a great UI in Thunkable will be the topic of another day. So let's come over to the, but while I'm here, we need, everything in this is components. So if you search, and we'll just say web API, so data, I want to make a call to my ESP8266 server. And so I'm going to drag this on, and it's not going to put anything on the screen, but you'll notice it put it up in the tree here. And there's this invisible components and visible components up here. The first one being the screen, which is the full screen here, and then we put one button on the screen. But under invisible components, we put this web API 1. And what that allows us to do is over here in the blocks, we've got web API 1 now as an option, and we've got all these different blocks to choose from. And so what I want to try to do, if I were writing an app myself, what I need to do is I need to make an HTTP call to my, I always have to reach up under my mic, my Feather Huzzah 8266. And the block language, I need something that resembles that. And so I want to call a get. And again, this is the type of request you're, whoa, why did it do that? Oh, you can change it, but I don't want to change it. Can I just go back to, there we go. From web API set URL. So this is where let's just drag the call get. Yeah, okay. Get, and then response status error. Wow, okay. Can I just drag this down to like the trash can? From web API set body, set headers, get query parameters, set query parameters. So I'm going to pull this out for now. Oh, and I have this one right here. Okay. And I'm going to click that in there. It's a little awkward in the thing. Like you have to like position this. I'm trying to point at the screen. Right where the little notch is, and you see it kind of highlight there. Let me make it a little bigger just so it's really clear. Right here on this notch, you want to align it with this notch to lock it in. So, and you'll see it highlight when it's there. See, highlights. Okay. So I want to call get, but before I do that, so let's pull this out. This is where I'm going to have to set the URL. Okay. So from Web API, set URL. Let's drag this over. And we want to set the URL to http://192.168.1.17. Again, this is just from your output. When it starts up and it says web server started, well, that's the old code. It'll say it right here. Where is it? Where did it start? Anyway, it gives you the IP address when you first get started. And so it'll just be in your console output. 192.168.1.17, and I'm going to say /voice. Because again, that's what we set in the code, in the Arduino code. So we're going to set the URL to be that, and then we're going to make a GET request. So we're going to just chain these together. So after we set the URL to that, we're going to call it, and then the response, what can we do with the response? Like, uh-oh, what'd I break? I did something. Can I just hit Control-Z? As if I put it in the trash can. Okay. What if I double click on it, right click on it, add comment, collapse block, undo last. So it has output status error and response, I guess. Again, I'm very new to low code, no code. So we're going to set the URL to voice. We're going to call it as a get. And remember, that's just there's different verbs in HTTP. You'd have to look, do a little bit of Googling on that. There's get, post, put, delete. There's a bunch of them. Mostly we're going to do get, post. For this example, we're just going to stick with get, like just to keep it simple. So we're going to call it, and then when get is done, we're going to want to do something with the response. And I'm going to say, do text to speech, speak. I wonder if I can just take, can I do this? Speak the response? I feel like there's got to be, we want to get the body. Let's not do that. Because the response is probably going to contain things like the headers and all that other stuff. So let's just try and do that. Get body. Yeah, because we don't want it to I don't know. Let's just try this. Let's just see what happens. Let's clear out the serial monitor. And then this, again, should be live on my phone. So let's grab my phone here. And I'm going to push the button and see what happens. Nothing. I'm going to try it again. So I'm not even getting anything in the output here. So we set the URL to that. Set, HTTP 192.168.1.17 voice. I wonder if it hates the fact that I'm trying to do it. Oh no, it hasn't gotten the updated code. How do I make sure it gets to the live test? Maybe if I just push that, it automatically does it. Let me hit view code here. So when I hit view code in the app, it's still not showing. It's not showing all of the code. So what are we missing? Let's zoom out. Did I put a block on here that doesn't belong? No, it doesn't look like it. Okay. I'm not sure how to like refresh it from here because I'm looking like on the app, like all the blocks are still scattered everywhere. And so I'm not sure how to refresh it. I'm going to go back. I'm going to just come back into it. And then let's do view code. Still not updating. I wonder if I have to like hit like Control S or something over here. Nope. Cancel. Well, open to suggestions. It's like it gets out of sync or something. I'm going to refresh it again and see what happens. Okay. All right, now let's come back into our code here. View code. Okay. I got when it works, it's like magic. When it doesn't work, I just refresh stuff, I guess. It's kind of weird. I mean, you're not getting any errors or anything. So now all the code is here. And so I'm going to try and press the button again. We should get something this time. Nothing. Okay. So the question now, and this is where I'm a little concerned with the low code, no code. What do I do now? Like, how do I debug this? I'm setting the URL. I'm going to reset our feather huzzah just for kicks, just to make sure I still get some output. There we go. 192.168.1.17, HTTP server started. And I'm going to press the button. I knew we couldn't get this done in an hour. All right. So it doesn't even make the call. And my guess is, if I had to guess, it's because I'm trying to go across the local network to say, hey, it doesn't like that. That's what I feel like we're hitting right now. What we could try maybe is like that. I wonder if the preview will, like pushing it right there. Nothing. Oh man. And if I wonder if I can come into like tools here, it'll say, here we go. Build with it. Oh, what is it? Web build 192.168. Okay. Let's clear this. X.Thunkable app. That's weird. Okay. Okay, so let's go back to how do I get out of this preview mode now? How do I go back to design? Like, how do I get... Oh, I just go back to edit. There we go. Okay. So let's come back to blocks. Why is it putting that thunkable? http://192. I wonder if I need to make a... I bet... Okay. All right. Let's do that. And I'm going to say... let's look and see what we get now. Preview. See, now it's saying get all this big old, like, what is that? Oh, maybe I just need to, there we go. Oh, HTTPS. It's not going to let me do HTTP. I bet that's why. I didn't say HTTPS, did I? Did I type that wrong? HTTP. Okay. So let's come back out to the design and see if Web API, here we go, URL, advanced. There's nothing in advanced. http://192.168.1.1. Why is it trying to .1? That's 17. .17. Headers, nothing. So that looks good. And there really is no advanced. Okay. And now back over on the block. Are there settings that I can... There's no settings that I can do over here. This is literally just the flow. So set URL. Is there anything else that we can do? Headers, body, query params, URL. No. So it wants to do it on HTTPS. All right, now let's see what it tries to query, though. Okay, it's automatically upgrading it to HTTPS. Okay. Well, let's not give up. I believe we can do an HTTPS server on our 8266. That's clearly what's happening. You can see here, HTTPS, even though I am definitely not typing HTTPS. If we come back to edit, slide this over, blocks, we're clearly doing HTTP. And so Thunkable is doing what they probably should be doing, which is like, hey, the net, IoT, all this stuff needs to be secure. You have to do HTTPS instead of HTTP. Okay. Back to the code. And I believe under examples, there is an HTTP. Well, these are all web servers. Okay, so probably this bare SSL is what we're looking for. This example demonstrates an HTTPS server that can serve / an inline. Okay, well, you know what it's time to do. We got to hurry. We got to take all the code again. All right. Third time is a charm, they say. All right. Let's paste it. Let's go back through and correct it. It's going to be Wi-Fi SSID and Wi-Fi password. Now we're creating a secure web server over port 443, and it's going to need a cert to do that. I also need to #include credentials.h here. Oh, man. Okay, server key, all that stuff, great. LED, this doesn't really even work though. LED, built in. All right, and we're going to say handle root is just text plain hello from ESP8266. You know what I'm trying to say. 8266 over HTTPS. A not found handler. We're going to do the setup. We're going to say connected. You have to get the time from an NTP server because HTTPS TLS requires timestamps to like validate the servers. The certificates are still valid. And so we are again going to remove the SSID. We'll just say connected to Wi-Fi. And what else? IP address, it'll show us. Set the cert, all this. Server.on, handle root on. We're going to change this to voice. This has to work now. Save it. Okay, let's upload that. Wonder how much space it's going to take. HTTPS takes a lot more than HTTP. 34% of dynamic memory and 42% of program storage space. So you still have quite a bit of space to use for your sketch. All right, I'm going to clear the output. 95. Let's get the phone ready. Oh, we're at 1 hour and 2 minutes. You watch. It's going to work now, and we will just miss the hour. Okay. We're still 1.17. I'm just going to push the button and see what happens. Nothing. However, we might need to refresh all this, so let's change this to HTTPS. And then let's run it. Let's preview it locally, actually. Design, preview, get rid of all this. Ooh, we didn't get a... So let's see the network. Clear. Like that. Voice. And failed to load. Ooh, why? What happened? Provisional header DNT, preview, response, initiator. But what's the problem? It should respond. Failed to load response. Why? Cert authority invalid. Oh man, you gotta be kidding me. Making it hard. So what that tells me, goodness, is that this cert, whatever we're using up here, is probably no good anymore. I don't know. Let's make sure that this is updated. Let's make sure the code's updated. HTTPS, it's updated here. Okay, so it should run from the phone. Nothing. And we're not even hitting. Nothing over here is happening. All right. Oh, wait a minute. Oh, yeah, it is .17. It's just, it looks like it's .1. Error cert authority invalid. Authority invalid. ESP8266 web server. you don't want to do a cert like that. So what this is trying to have me do is generate my own cert, and then I've got to allow it in Chrome. Like, that is such a hassle. I do not want to do that. Oh, we might be stuck. Let's take this. Let's switch them around. It's the same thing. What we need is a cert that's going to work. 6509 RSA key. Set server key insert. How are we doing that in our code? Set RSA cert. Server key and server cert. RSA key. Let's try another approach to this. Let's search the issues on the repo, because this is from latest commit was over a year ago. That's probably not helping us. Let's search for nope, that's not what we're looking for. Well, let's actually come into here into examples, and we'll do not client, web server. Yeah, but this is going to be the same. I almost guarantee. Server cert. It looks awfully similar. Yeah, that's the same. And then the server key, MIEPQ. That looks the same to me as well. Okay, so Brave doesn't like it. Android doesn't like it. Oh, that's handle root. Oh, yeah, handle root is right here, not voice. But I changed it to voice, right? Change the code to voice. Yeah, it's going to voice. So let's just do https://192.168.1.17. What do I get? Your connection is not private. And the reason Certificate is invalid. There you go. Expires on March 5th, 2019. So I need a cert that works. ESP, man. 66. You're telling me that nobody, see, this is from 2019. You're telling me nobody's done this like recently? I don't want to generate my own certificate. Like, I don't. Um, hmm. And I don't know what to use. I'm not a. Brr. Oh, that's way old. It's not going to work. This is probably equally old. So this wouldn't be a problem if Thunkable would let us hit HTTP without HTTPS. I get why they don't. Like, it's smart. But man, that would make our job much easier. Hmm. All right. Authority invalid. Internet widgets. Like, that's weird. Downside contains public key and a private key that will use to encrypt information from the applications. They're using a self-signed generator or using a commercial certification authority. Do not reuse the certificates included in the examples provided. Okay. All right. Let's just see if we can. I mean, will a self-signed work? Man, if I can get this to work, this will be a great write-up. I don't know where it's gonna key out. It's gonna just output it right there. Let's do a CD downloads make dir server certs. And now let's run it. You are about to be asked for permission. They'll be incorporated into your certificate request. Fields, but you can leave some blank. For some fields, there will be a default value. If you enter dot, the field will be left blank. So country name, great. State or province name, Utah. Utah. Locality name, I don't know. Salt Lake City. Organization name. Oh, there you go. Internet widgets. That's why it's that. Maker crew. We're Maker crew around here. LLC. We're just, if you enter dot, the field will be left blank. Common name. I don't know. Let's just type Maker crew again. Email address. Okay. See what happens if we just leave it blank. Oh, CD server certs. What? Where did I put it? Does it put it in like... What the heck? Ugh. Why? Key.pem, cert.pem. What's the problem? Oh, I didn't change. Daggone it. Okay. It's because I was in the directory. I'm starting to get tired. All right, dot slash whatever. Key dot pem and copy cert.pem. Thank you. Okay, and now if I just do something like less cert.pem. Okay. Okay, that's the cert. That's the cert. So let's just replace it. Cool. All right, save. And now let's do less key.pem. The window's not big enough. There we go. Okay. And we're going to do that. I have no idea what I'm doing right now. I mean, that's not entirely true. I know a little bit what I'm doing right now, but not exactly. Okay. Now that we have, well, let's just try and program that and see what happens. Let's see if Chrome at least will take it. Hmm. Hmm. Almost there. Let's watch the output. Okay. Server started. Let's try this again. Privacy error. Whoa. It crashed. It crashed hard. Well, that's a good sign. Okay. Okay. It blew up. Maker Crew. Oh, look at that. It's it expires in the year 2032. Um, okay. But why is it insecure? Details. It's the right certificate. That's the certificate we just generated. But it did kind of like barf all over itself. Let's see if it crashes again. I'm going to pull this off the screen. If anything interesting happens on it, I will show you. Okay. So the certificate is working. Hmm. All right. Well, it didn't blow up that time. What happens if I try and do this from Postman? Let's just do HTTPS. We're going to say, did we change it to voice? Voice. Yep. All right, let's just try that. And forget like Chrome. SSL or self-signed certificate. So we can disable SSL verification. I'll see what happens. Okay. It does work. But I had to, it doesn't like my self-signed cert. Okay. And if we just get that, man, it takes a while. And voice. Well, let's at least try. I don't know. Let's at least try. I doubt my phone's going to like the fact that the cert is self-signed, but I don't know. Let's try it. I assumed as much. Okay. All right. Well, so Thunkable doesn't allow HTTP. It only allows HTTPS. That's what we're learning. And it doesn't. We could get this to work if we could get a valid cert. Let's just try one more thing. Let's encrypt X3 cross sign. Like, can we get a cross? Like, I want to get upcoming cross-signing. Document, like, how do I get? Let's get started. You need to get a certificate from a certificate authority. Let's Encrypt is a CA. In order to get a certificate, you have to demonstrate control over the domain. But we're not hitting the domain. We're hitting just an IP address. Let's encrypt server cert for local address. Certificates for local. It's not really local host. All right. From what I can tell, and thank goodness for internet security, the only way I'm going to be able to get this done is if I add this certificate. So let's just do that, just to test. Add cert to Brave web browser. Oh, add a self-signed cert to Chrome. And then I'll figure out, I'm sure there's a way to put it on my phone. I'm not giving up on this. Certificate. Here we go. Wait a minute. What are we talking about here? View certificate. So let's do this. Let's go advanced. Proceed. I'm going to pull this over here so I can look at it while we're... Hello? Over in the developer tools, we're going to go to security. Okay. Details. And then we'll say copy to file. No, we can just say export, but I don't want to do that. Like, I don't have to do that. Yep, great, great, great. Page 2. Open Chrome settings. Show advanced settings. Isn't there a way to just do like Settings. Help me out here. Brave settings. There we go. Brave settings. Additional settings. I'm going to pull this off screen because I just know it's going to show something that it's not supposed to. Let's search for manage certificates. Okay. You have no certificates. I'm going to hit import. And I am going to go find my certificates. Okay, this is where... Okay. This is where I do need to come into here and then say export. Maker crew. What do we want to save it as? The article told me. And I didn't want to listen. It wants it to be an SSL client certificate. Well, it's gonna, whatever, save. Single certificate, whatever, save. All right, now I'm gonna try and import it. Not found. Okay, so let's try and export it to something else. Private key. Oh. The private key. Okay. Okay, I don't know how to add it. Yeah. All right. Okay. I'm calling it. I think. And then I'm sure there's a way to add a cert to that, but it would be nice if I had a low code option or no code. I mean, I really like how Thunkable integrates, though, that allowed me to do HTTP. If we could just do HTTP instead of HTTPS, but we really want to do HTTPS. Like, why would we want to do HTTP? Like, they don't let you do it for a reason. All right. I'm going to have to think on that some more. I'm going to end the stream. We failed. We spent an hour and 34 minutes and couldn't make it happen. So I'm going to think about it some more. I'll research it some more, and then we'll see if we can't get this to actually work. If we do, I will definitely show it. So otherwise, hope everybody has a fantastic rest of your weekend. I'm sure I will see you next week.